Yeah. So let's see, like a few people can join in between. They will catch up. So I think we are good to start. So it's Harish. I'm the host for today. Uh, so good morning, everyone, and welcome to the live webinar on AIML conducting by Innovit Technologies. The motto behind our webinar is to create a high quality AIML content accessible to all and bring industry relevant experience to all our users. So today we are thrilled to have Nishi Paul as our mentor. She's a data scientist too at HP Enterprises, and she has also worked with HSBC and MIQ. And she has a wide range of experience in AIML application in multiple domains like banking, advertisement, and IT. So today is day two of our webinar series, and the topic is AIML for beginners. And I finally thank everyone for joining us today, and I hope today's webinar will help us in understanding more about AI. I hope we are good to start. Over to you, Nishi.
Oh, thank you so much for the introduction. Please give me 2 minutes. I don't know, somehow the meeting got disconnected. I am trying to log in again.
Sure,
Just 2 minutes.
sure, sure.
Hello, sorry for this inconvenience. One second, I have to mute it. Yeah, so I'm having some issues around our area, so there might be some inconveniences. Sorry regarding that part. Okay, so we will get started. Okay, so I'm sharing my screen. Okay, so today's topic is getting started with predictive modeling with AI. Now, in our last webinar, we had a brief introduction of what artificial intelligence is and what are the different kind of parts involved in it, and we have also seen the different applications, web applications, and the API usage. Today we are going to create few models from scratch, and today we will be working with the machine learning models specifically. In the upcoming webinars, we will go to the deep learning models and then to the generative AI and then to the LLMs. That's how we are going to proceed. So, getting started with this machine learning is useful because that is the base concept and that is from where we had started with the modelings. So, just to give you a brief intro on what machine learning is, you already know about it. It's when the computers are learning. So, I'm not wasting much time over here and I'm proceeding with the next slide. That is the machine learning types. So, machine learning can be divided into multiple times depending on how we are working with it. Like it is, it can be divided on the basis of human supervision. What does it means that if you were supervising the machine, that is a supervised learning, we had done that before. Then comes the unsupervised, then comes semi-supervised, and the reinforcement learning. These are the types that you can expect out of human supervision. Now you can again pick up another type on the basis of if you are training your model incrementally or if it is a batch learning. What do you mean by the batch learning? It is when we are picking up the files and then we are training the model with a huge set of data altogether. So it's like a static data. The data is not changing with time. When we are talking about the incremental data, it is a complete flow. And normally, whenever the machine learning models are in production, they have to be, they have to be that much, they should be having the capability to have that incremental learning in it because the production data will be continuously flowing in it. So that's how you can segregate it as well as incremental and also as a batch learning. Today we are going to go through the batch learning concepts because while building up the machine learning models, also be it in industry level or be it in research level or educational level, we do start it with the batch learning procedure. We look into the outcomes, and if the result is satisfactory, then we do the production level building of it, and we develop the incremental part to it, that is so that it can enable that incremental learning on the go. Okay, and the third type is if you are utilizing the model as a predictive one or as a comparative one. What do you mean by this comparative one is that if you take an example of I'm giving you an apple and if you're picking up another apple, it's like you're comparing both the apples to see if they are same or not. That is what the comparison is. In terms of this machine learning concepts, we can do the comparison also. We can set up, build up certain codes, certain lines of code using the regex expressions mostly, where it will do the comparison, it will search for the patterns, and then it will give you the result. That is one of a kind where you are actually telling the model the types that you would want out of it. And we do use it normally in terms of a part of it, I will say, in recommendation systems, this comparison type of work. And the next sort of work is the pattern recognition by the model itself. That is more of a predictive modeling. So both of it is coming under the type of it. Okay, so next is getting into the predictive modeling that we are going to be doing today, and which is very much in demand or which is getting utilized in most of the applications running around the world today are the supervised and the unsupervised learnings. So first, starting with the unsupervised learning. Okay, So up to this point, I hope we are clear with everything.
Yeah, continue.
Okay, thank you for the confirmation. Okay, so let's get started with the unsupervised modeling. I'll give you a brief theory on what unsupervised modeling is, and then I'll go to the project to show you what kind of applications can we expect in the real world scenarios. So, the unsupervised modeling categories that I'm going to show today involves clustering and the dimensionality reduction. Now, there are many other types that falls into this that we have seen in the last webinar. So, sticking to this clustering and dimensionality reduction, what are these? Let's take a look. So, clustering is a technique of unsupervised learning in which we are performing the clusters. That is, we are creating the clusters of data points. Similar data points will go together, unsimilar data points will have the maximum distance in between them. That is how a cluster is getting formed. Simple as it is, just creation of clusters. So, what are the models which facilitates this cluster formation? There are multiple models. Today we are going to use this k-means clustering. Now what this k-means clustering is doing? In this k-means clustering, I'll move to this picture for a better understanding. It is when, suppose you're having this first picture where you are having so many data all together and all are green data points, right? So you have this sort of data in the structure, but how can you now segregate it, or how can you now create clusters out of it? You can create the clusters by looking into the similarities in between the data points. So in future, you have two more data points, this red mark and this blue mark. In which of these two clusters should these data points belong to? You do the similarity calculation. How you do that? You can do that in the form of a distance calculation. You can do that in the form of, let's say, there are many Euclidean distance calculation, there are Minkowski distance calculation. And by this calculation, you can say that a red point is lying, let's say, on the left cluster, and blue point belongs to the right cluster. That's how you are performing two different or completely separate clusters. Why do we need clusters? This clustering method is getting utilized at several points in real life scenarios, in real life applications. The example that I'm going to show today is the customer segmentation, which is getting used in the marketing hugely. So why have I picked up this marketing related project? Because this is a booming industry right now, and most of the profit, every sort of these big organizations are deriving out of marketing only. So that's why I've picked it up. But this application is applicable to every other sort of be it a customer or be it any kind of, let's say, product. You have multiple products with you, and you want to cluster all the products according to its similarities. You want to see which of the products can fall to a particular cluster, so that you can take actions on top of that clusters accordingly. So this concept can be applied to multiple places. Now let's go back. Let's go to the next slide to see what this hierarchical clustering is. I hope it's visible. It's quite dark though. Okay, so hierarchical clustering is of two types. One is agglomerative, another is divisive. What is agglomerative is when you are starting from the bottom and going up to the top. You are starting from single points, you are then joining the similar points together. Thus, you are getting a bigger cluster than before. Then you are joining more similar points or more similar point groups together. Then you are getting a bigger group, and in this way, you are creating clusters. That is what agglomerative is. Divisive is just the opposite to it. You are starting with a big cluster, and then you are dividing it into smaller parts, and then you are ending up into the smaller clusters or the smaller data points. So these are the different types of clustering methods available. Another one is the density based clustering, which is going to show you or the clusters on the basis of the density of the points, that is density of the data points. Now, the questions are, what do we actually mean by these data points? The data points are nothing but the features or the columns that we have in the real life. Now, the real life data are mostly in the form of text, they are not in the form of numbers. What do? We convert those text into numbers so that they can be represented in the 2D format, so that they can be not in the 2D format. 2D format is just for us to view it, but they should be representable in a dimension, let's say. And then you can perform the clustering. There are multiple types of clustering, and this totally depends on your business use case, on your data set. There is no one model, there is no one perfect model. You need to go through multiple models, you need to go through the output of each one of it, and then have to say which model is giving you the best result, and then we normally go with that. So today's project, the first one is the customer segmentation. That is an unsupervised learning project, and we're going to use the k-means clustering with it. Okay, so moving to the Jupyter notebook, I'm using the Google Colab notebook over here. Okay, so up to this, we are fine. Is clustering clear to you?
Yeah.
Okay, great. So next, moving to this customer segmentation using machine learning. This is an introduction, like what this customer segmentation is and why do we do it. Customer segmentation is important because there are multiple type of customers, and even if we look at us, we all are different. We all have our own expectations, our own lifestyles, our own values, our own demands, and clearly providing customer type A is not going to be the same as providing customer type B. They are having their own requirements. Understanding that requirement is quite important. That's why clustering the customers is quite important, and that's what the customer segmentation is. So at first I imported some of the libraries which are required by us. And okay, so over here, I would like to tell you these are some of the functions or the classes, more appropriately, that I have derived from this sklearn library. And at any point, if you find any kind of confusion, you can stop me and ask me questions about this. Okay. I have briefed the complete thing over here for you to understand it whenever you go through it. Okay. So the first step, what we need to do is to import all the libraries. The next one is to import the data set. Now this is the detail of the data set, and the data set is the one that I have derived from Kaggle. I have downloaded it from there. I have placed it into my Google Drive and imported it from there using the pandas read.csv. So this is how our dataset looks like, where we have the ID, the customer IDs, the customer age, gender, income, education, and these are all the columns or the features related to every individual customers. And we have about 1 lakh customer dataset over here. So there are 1 lakh individual or unique customer dataset that we have with us in this. Okay. So the next step would be to perform the data exploration at first. That is, we would like to know what kind of data we are working with, because it is a very common saying in terms of machine learning models that garbage in, garbage out, right? So we have to work with the data set in a very proper format that the model would expect it to be. So then we looked into the data information. Like we want to know if there is any null values in the data, if there are any duplicates in the data, and we would also want to check about the data types of it. So using this info, it is showing us that there are 1 lakh non-null values for all the features, for all the columns over here. So that's perfect. We do not have to worry about any null values. We do not have to do any work around that. And then we saw that the data types, these D types for every customer dataset are
Hello. Are you speaking? Hello. I lost.
Hello.
Hello, we lost your voice from last, from 2 minutes.
Okay, sorry, this is due to some kind of problem going on over here in this with this internet today. I can see this screen sharing has not yet started. Okay, thanks for the confirmation. Try to share it again. Yeah, I think now it's visible.
Yeah,
Okay, so starting it from the beginning, I guess, with this customer segmentation. Okay, so customer segmentation is when we want the grouping of the customer as per their demands, like as per their requirements. Different customer has got different requirements and we have to fulfill it accordingly. That's why the segmentation is important. But the concepts which are present in this project is the similar ones that could be applied to any other clustering types. That is, any other clustering that could be applied on any other data type. Totally depends on the business objective, but the concept remains the same. There would be a little bit of changes based on the requirements, based on the data types, based on the different types of these explorations you want out of your data, but the concept remains the same. So customer segmentation is important. Understanding the customer is important for growing your business. Okay, so first step is to import the libraries that we need, and there are a few more libraries that I have imported on the go. So at any point, if you do not understand what the libraries mean, then you can stop and ask me. No issues with that. So these are basically the classes that I have imported from the scikit-learn library, and what this classes does, we will look into those code blocks specifically. And this is the information of the dataset that we are using over here, and I have detailed it all over here so that it is there and you can read through it multiple times or for better understanding. Okay, so this is the customer data set, and this ID over here denotes to the customer IDs, the unique customer IDs basically. And these are all the other features for the customers. And this data set, I have taken it from Kaggle. You can download multiple data sets from there and start working on it. So this data set is having 1 lakh records for the customer. So there are 1 lakh unique customers present over there. The details for them is present with us. The next step, before starting on with the model building, we should be very much clear about the data usage. So the data should be very much specific to how the model wants it. That's why the data exploration is important. You have to understand what kind of data you are using, and you have to put the data into the model in a way that the model is expecting it to be. Otherwise, if the data is not accurate one, your model output would be, I mean, it would be an error output. The prediction would not be the accurate one. Okay, that you can expect to use at production level. So this info function is giving you the information about the data set. And by this, we can see that we are not having any null data in our data set. As it is implying, there are 1 lakh non-null data set in every column, but there are object data types present in our data set. Now, what this object data type means, these are the string type of data, and we need to handle it because machine learning models cannot work with string type of data. It needs to be numbers. Okay, so looking into the values, what do we observe? We see that in case of gender, there are male and female. In case of education, there are bachelors, masters, and so on. So these are kind of categorical values over here, right? I mean, these values present over here in this object type of columns are not. They are not changing with every row. They are repeating, right? They are the categories. So we can handle it quite easily if it is the case. So let's see how many categories are there, the unique number of values basically in all the object type of columns. For that, I'm selecting the object data type and then looking into the unique, n unique, that is number of unique values in each of these columns which are of object types. And from there, I get this gender as 2, education as 4, product category as 7. So these are the unique number of values that are present over there. Okay, and by this you can see if there are any null values present or not in our data set. So okay, there are no null values, we can uh, go forward. And then this describe method. So describe method is basically a statistical summary which is going to show you how much dispersed your data set is. What does it means? If you see this one, this id column is anyway, it is not useful for us, so we will basically drop it later on. But if you look into this age, you see that the mean value is 30. If you look into the income, the mean value is 27,516. So the values are varying a lot, right? This value is quite huge and this value is quite low. And again, coming to this promotion usage satisfaction score, these are again 0.30, 5.0. So these mean values are quite varying a lot, right? They're quite dispersed. Now, that is where we need scaling. Why so? Because whenever this kind of variations in the data values will come up, if the scaling is not being done, then the features which will have these larger values like this 96, 9,600, 27,000, it is going to overpower the values which are having the uh, smaller numbers, basically these ones. Okay, that's why we should be doing the scaling before we are using it for the clustering purpose. And regarding that only, I have detailed it over here. Okay, so next we're checking for the duplicates in our data set. There are no duplicates. Well, that's good. So after that, we are dropping the ID column because ID column is not going to make use of in the clustering procedure. That's just a unique number given to every customers. Okay, that's a short data exploration in terms of numbers. Now the data exploration in terms of visualizations. So visualization means creating graphs basically, and it's important in terms of the fact that when you are visualizing in a graphical format, you can detect any kind of outliers quite easily. It becomes visible. And also the pattern, you can see the pattern quite easily. So the type of visualization available for the numerical columns and the categorical columns are quite different. So first, we will be looking into the numerical columns visualization, and I'm selecting the numerical data types in the same way as I had selected for the object types. And these are the numerical columns available with us. And this is the code description I had provided over here for the code which I have written here. Now, what this is showing us? This is showing us how the complete set of numerical columns are distributed in our data set. So this is age, the distribution of age, and this is where the frequency is. And this chart is showing us how uh, how each of the values under the columns are distributed. Sorry. So this histogram is showing like the age is quite well distributed. It's quite symmetrical. The income is showing almost the same across all the data, all the customer data that we have. But this purchase amount is showing somewhat a drop down at the end of it, while the purchase amount is increasing. So it shows that for when the amount is lower, the frequency is quite higher. That is, let's say if it is 5,000, then most of the frequency around this 5,000 is around maybe it's 2,100 or something. This is the count. But when the purchase amount is going beyond 2,000, the frequency is decreasing. So this is how you know how your data distribution looks like. All the customers are the customer purchasing amount is showing over here, the customer purchase behavior basically. And this is showing you the satisfaction score. So from here that you can predict that about 10,000 are satisfied at the score of 7. Most of them are neutral zone, and there are few of it who are in the third or the second category. So this is showing you the customer complete detail of it. Okay. Next is getting into the correlation matrix. So this correlation matrix, what does it means? Okay, so I'm talking for quite a long time. I would like to ask you now, do you know what correlation is? Can anyone tell me? Okay, you can use the chat or you can unmute yourself and let us know if you know about correlation. Okay, so Kartik is saying relation between data points. Exactly, correlation is telling us the relation between data points. Uh, yes, like how much one feature is related to another feature. Okay, so it's not just in that format. I mean, there are two different concepts. One is the correlation, another is the causation. So this correlation is giving us the relation between the features. Yes, relationship between random variables. Okay, like having the same trends. Okay, yeah, right. So yes, having the same trend is more of an appropriate term, I will say, because it states, this correlation states, if you're having two features, two columns, column A and column B, then if your column A is increasing, how much is your column B increasing or decreasing? So, how is column B behaving when column A is changing? That is what a correlation is. And correlation is always in between the numbers. It will only take place with the numerical columns, and the correlation value is in between -1 to +1. -1 is indicating highly negatively correlated. That is, if the column A is going up, column B will go down. And this correlation of 1 indicates that if the column A is going up, then the column B is also going up. That is, they are in the similar direction. They are highly correlated. We say it in a positive way or in the negative way when they're in the opposite directions. Okay. So from this, what we see that income is highly correlated to purchase amount. So income is showing as 0.95 and the purchase amount, the correlation value is showing as 95. So we can say that they're 95 percentage correlated. Okay. And for the other columns or the other features, we don't see any significant correlation in between them. So we have to consider all those features. But in this case, we can consider any one of it. We can consider both of it. I have taken both of it in this scenario, in this project. But the more appropriate scenario would be to take any one of it and then to see what we are getting by picking up just a single column and eliminating the other one, since they're highly correlated. Okay, that's another way. So as I was saying, that there is no one perfect model. We need to test around multiple models. We need to test around multiple data formats. Like in this one that I'm showing over here, I have picked all the columns, but you can create maybe another copy of it, and in that you can eliminate this income or the purchase amount and then see how this clustering is performing. That is another way. Okay, now this is another type of plot, and this is a bivariate plot. Why so? Because we are showing we are looking at two different features over here at the single time. That is, we are looking at this age, we are looking at this income. Okay, so this is how the age and the income is varying altogether. So there is quite a flat line over here, and then again it is increasing, right? So these are all the different kinds of exploratory data analysis that you can do around your data. Okay, so enough for these numerical features. Now getting into the categorical features. The categorical features we have are this. And this is how the distribution is looking like. And the code is same as that I have used for the numerical features. The only difference is in the plotting. With the numerical, I used the histogram plots, and with this one, I used the count plots, which is somewhat like the this box plots, these bars over here. So what we have in this, the distribution of gender, they are almost the same. Male and female distribution of education. Seems like college students are most in this data set. And this is a loyalty status. The regular customers are more over here, and different kind of this visuals, different kind of analysis that you can derive out of these visuals. Okay, and you can also look into these categories as per these pie charts. This is another way to look into it, the distribution of it, right? Okay, so enough for that exploratory data analysis. And this is not, this list is it has not yet ended basically. So you can go to the scikit-learn. There you will get many more different types of distribution, many more different types of visualizations, and you can use any one of it looking into your data distribution pattern. That is, if it is a categorical, then if it is ordinal or not, and then if it is a numerical one or not, if it is a time series data type of a thing that you have with yourself. For that, the exploratory data analysis would be a different kind of a thing. So the list will go on. There are many things that you can derive out of it. Okay. So getting into the conversion, how you can convert the categorical columns into the numerical ones. There are multiple ways. Okay, so the first one is, when we looked into the gender, we saw that there are only two genders, male and female. You can simply use this map method to map the male to 0, female to 1, and that's done. I have saved it into this column of gender encoded. Okay, next is, we looked into the product category. Now, the product category, these are the categories, but they are not ordinal. Now, what do I mean by ordinal? Ordinal is something which has got a relation in between the categories. Like the best example would be to it is considering the students in a class. So the ranking system for the student is like first, second, third, fourth. So this first, second, third, fourth, these are also the categories, but they are ordinal. Of course, the first boy or girl, they have to be at the first rank, and then at the second, then at the third. So there is a ordinal relationship. There is a hierarchy, basically one coming before the other, and like that. But in case of this product category, these are books, clothing, food, electronics. There is no ordinal relationship as such. If it is not there, then we will perform one hot encoding. Now, what is this one hot encoding? One hot encoding is basically converting your data points. It is picking up your columns and uh, okay, I see Karthik commenting. Yes, right. It is converting it into 0 and 1 binary values. It is picking up your features and it is giving it a value of 0 and 1. How it is giving up? If the value for, let's say, we are considering for the books. Now, the record number 2 is having book in it. And if I'm performing one hot encoding in it, then the record number 2 will get a value of 1, because it is having the book in it. And if it is not having the book in it, then it will be a 0 over there. So it will be more clear when you will look into the data set for this one hot encoding. But yes, the one hot encoding is basically transforming it into a binary value. It will pick up all these product categories, and then it will create new features for additional features will be created. If there are 7 categories, then 7 additional features will be created with its value as zeros and ones, indicating if that feature is present in that record or not. Okay, so this is how the shape of the data set is before and after the addition of these one hot encoded features. Right. Next one is the case for ordinal relations. Okay. So when you consider this education, bachelor's, master's, high school, college, of course there is some kind of ordinal relationship in that, right? You cannot be in a college without completing your high school. So we can do a label encoding in it. We do not necessarily have to perform one hot encoding. We can perform the label encoding. What is the difference? In case of one hot encoding, it is giving you a binary value 0 and 1. But in case of label encoding, it is going to give you the numbers like 0, 1, 2, 3. In this case, since we have 4 values. Okay, so let's see how the data set is looking like for a clarity. Now, in case of the category, this is what the product categories were before. Okay, and after the one hot encoding, this is what we got, product category books. Now, looking into this first record, here we have this product category books as a value. And when we did the one hot encoding, this product category books, a new feature got created with its first record value as 1. In the second and the third record, the product categories are clothing. So these books are showing as 0 and 0. This product category beauty is also showing as 0 and 0. But this clothing over here is showing as 1 and 1. So that's how this one hot encoding is working. What about this label encoding? So the label encoding over here that we have encoded is the education. This is education encoded. We can see it 030. So how will you know that which out of this is encoded to 0, 1, 2, or 3? By this enumerate and this label encode class variable, classes variable it has. So this class bachelor is assigned to 0, college is to 1, high school to 2, and masters is to 3. And you can verify it. This is 0, and let's move back to our education column, and we can see that it is where it is bachelor's. Yes, it is 0. That's how you can see that, okay, your labeling is correct, right? Similarly, we can perform this label encoding to the other columns like region, loyalty status, and the purchase frequency. Okay, now one thing is we are performing one hot encoding and we are also performing label encoding. What is the difference in between this, and why do we need to perform it in different ways? So when we are performing clustering, as we saw in our k-means clustering graph, or what we have understood is that there is a distance calculation. So if this distance calculation is a fact coming up in some kind of models, then the numbers that you are using as a value is quite important. Because let's say the label encoding as 2 minus 1, the difference value is 1, but the label encoded values such as, let's say, 5 and another is 1, so this 5 minus 1 is 4. So of course this 2 is a lesser one, the difference, and 4 is a greater as a difference. Now this 2 and 1 points will be closer to each other. 5 and 1 points will be away from each other because owing to its difference, right? So that's why when we do the encoding, we have to be very much sure about what are the encoded values we are putting onto the categorical values, right? Are we clear at this point about this one? Okay, great. And what about others? Are we clear about this label encoding and the one hot encoding and why this kind of encoding is required? Mainly because of the distance calculation. Okay, great. So moving forward, we have done the label encoding. We have done most of our data pre-processing that we could do with this data set, and then we arrived at this solution. So we have a fairly clean data over here where we have all these columns as integer types or the numerical types rather. Next one is the scaling. So the one thing that I was describing in the beginning, right, that we need to have it in us at a similar scale because of the same reason, because of the distance calculation reason only. Like, right. So if you're having it of a multiple different scales, then the larger values are going to overpower over the smaller values. So we need to have the complete data set in a similar scaling so that all the features gets same importance when the model is performing actions on it. So how you do the scaling? Initializing the standard scalar, then fit transforming the customer data set that we have, and this is how my scaled DF is now looking like. These are all the values, the scaled values basically. Okay, and if you do the describe, then you see the mean is quite similar. They are falling in a particular range. Now it is not varying by a huge number. Okay, and looking into the correlation matrix, this is how it is right now. So previously when we did the correlation matrix, we just saw it for few of the numerical values. Now the correlation matrix is a huge one simply because we have encoded all of it. Now our categorical values are numerical, and by that we see that this product category electronics is somewhat highly correlated with product category clothing. Okay, and this will be actually quite you can visualize it quite well when the model will perform the clustering on top of it. We will see that. So this is done. We are ready with our model building. Our complete data pre-processing is done, and this is what our model should be like right now going forward. Okay, so before performing this k-means clustering, There, we saw that this kind of clusters are forming, right? Now, when these clusters are forming up, how do you know how many clusters you would want out of it, right? So, in order to know the number of clusters, what we need to perform is something like this, an iterative nature of k-means model training we need to do. So, what we are performing is I'm just giving it a random value from 1 to 11 in order to search for the perfect cluster at which I can expect a better accuracy from my model. Yeah, right. We need to define the k value, but before defining the k value, how are we going to know which k value is the right one for it? That's where we use this method. There are two methods. One is this elbow method. I have described it completely over here, and another one is the silhouette method that also I have described it over here. So what this elbow method is, I'm just giving over here a range from 1 to 11, and then I am performing the k-means model clustering. Okay, this is how we are defining this k-means model, and I'm just creating or initializing the model. I'm fitting the model with my dataset, the scaled dataset, and then I'm looking into the inertia of it. This inertia is basically indicating the sum of square distances in between the data points. That is the cluster, in the clusters, the data points that we are having, it is going to calculate the values or the distances in between the data points, and then it is going to assign the data points in a single cluster for the ones which has the minimum of distance in between them. Okay, and this is an iterative one where we are looking into this inertia. So after that, we are plotting it up the number of k values, and what we get is somewhere around 7. This is the elbow. That is, it is going down, down, and somewhere around this point, it is there is a sharp turn. Okay, this is the elbow point. Now, to be more clear on it, we can use the silhouette method. And in the silhouette method, okay, in the silhouette method also, we are performing this similar things. That is, we are using the model, we are fitting the model with our data set, and then we are performing the silhouette score action on it. Okay. Now, the silhouette score, if it is a 1, then it will mean that the data points are well clustered, and if it is a 0, that means the data points are basically on the boundary. That is, it is not belonging to any of the clusters really. And if it is -1, that means the data points are wrongly clustered or grouped into the wrong cluster, rather to say it. So with that, it does a scoring and it will give you a scoring. And from there, we see that the highest score is at around cluster 7. And in the silhouette score, we take the highest score point. So this is the highest score as it is visible, and it is at the point of 7. So clearly, k is equal to 7. The value of k, or the number of clusters, should be 7 as per the elbow method and the silhouette scoring method. So this is our final model where we are providing the number of clusters as 7, the random state as 42. The random state we are basically giving it as 42 because we don't want the values to change multiple times on running it. Okay, the data points basically, we don't want to change it. And then we're fitting the model with the scale data set, and the clusters that we have got, we are assigning it to the column called as cluster into our customer data set, into the scale data set, and into the original data set that we had kept a copy of before, right? Why so? Let's see why. So then this is done. The model part is done. The model prediction is done. Now the part comes for the visualization. So you have got now 7 clusters, right? For these 7 clusters, how can you visualize it? It will be quite difficult to visualize 7 clusters means, let's say if we think of it as a 7 dimensions, how can you visualize it, right? But to more appropriately, if I say it, we have got 12 or 12 columns, if I'm not wrong. Let's go back, 16 columns, sorry. We have got 16 columns. So how are you going to visualize the 7 clusters across 16 columns? 16 columns would stand for 16 dimensions. It would be very much it is very much impossible for us to visualize that kind of a structure, right? That's why we use this PCA. PCA is a PCA is a decomposition method, and I'll show you the presentation now to look into the fact what this dimensionality reduction method is. So this dimensionality reduction is basically reducing the number of features for us. It is keeping all the important aspects of the features intact while doing so. Why so? Of course, for increasing the efficiency for us to see it, for improving the visualization, so that we can see how, no matter how many features we are having around, we can better see how the output is behaving with all the input features, right? That's why this dimensionality reduction is important. And the one that we are dealing with over here is PCA, Principal Component Analysis. So, what is that? This principal component analysis is basically it's a kind of an advanced concept, but what it does is it is transforming the dimension towards your data set. Okay, so I mean, it's quite hard to express it in terms of words because there are multiple techniques involved in it, like the calculation of eigenvectors and the eigenvalues. ES, right? It is a hyperplane, we can say it. It is splitting up the data, or rather, the the plane gets adjusted in a way so that the data gets split up accordingly. I mean, yeah, the plane adjusts itself as per the data arrangements in your space with the help of the eigenvalues and the eigenvectors with the covariance matrix calculation. So basically, if I say it in simple terms, PCA is for dimensionality reduction. It arranges the x-axis and the y-axis in such a way so that you can have a clear view of your data set segregations, okay, in the lower dimensions. So that's what we applied over here. PCA component 1 and component 2, and there you go. There are 7 clusters. So from here, as you see, this cluster number 0 is quite separated from the other clusters, and this cluster number 6 and 5, it somewhat merges, right? 6, 5 and 4, it somewhat merges. It's probably because of the some of the product categories were showing some correlations that we saw, right? And then there were income category and the purchasing amount, which were having a high correlations, but we have taken that into consideration as well. So these merging points are probably coming up because of that reason, but we need to check it out by removing those columns and then training the model once again. Okay. So going along with this one, this clustering, these 7 clusters that we have got over here. Okay. What have we got? Let's see. So these are the cluster centers. Basically, I have created a different data frame by considering the cluster centers. That is, I have created just this a data frame out of these 7 clusters. Why so? In order to understand the feature importances out of it. So these are the clusters, right? So you might want to know, if I'm having the 7 clusters, then which of the columns or which of the features are influencing those clusters the most. Of course, as expected, it's income, purchase amount, and it's giving you the value. So here, this product categories in each of the in this cluster of 0. Sorry, not the 0. In each of these clusters, this electronics books or this clothing, it is putting on similar effort, right? It is putting on similar importances in each of the clusters. And that is the reason basically we are having 7 clusters because of the 7 product categories. And that is quite visible when we did this. That is profiling. Now, your work is almost done. You have the customer's data set. You did the cleaning. You used the model for the clustering, and now you have got the 7 different clusters. That is, we can say 7 different groups of customers. Now you can give this data to any of the persons, to the digital marketers or to the business persons who are concerned with targeting those customers in a way. So they might have their own sort of um, own sort of ideas for targeting those customers in a way, but your job is done over here. You have this 7 customers and 7 set of groups, and you can just let them know, I have the 7 set of groups, and these are the basically features around the 7 set of groups. And you can suggest them also, right? That what I have observed is this cluster number 0 is having this kind of an age group. Let's say the cluster 0 mostly is observed around the age group of uh, let's say 30 to 25. So and they have been seen with a loyalty score of silver the most, target them in that way or something like that basically. So you have the clusters ready with you to see. Let's see, this is the cluster number one, and if you group it by the gender and education, you see that the cluster one has got most number of females and males around this uh, bachelors, and the college is the most number of the females and the males they have got in cluster one. In cluster two, the college is quite lower than that of the cluster one, right? And this is, I think, it visualizing is very much effective when it comes to the decision taking. So what this is suggesting is that by looking into it, we can say that in cluster one, the persons who are having the age of around 30 and who are in college are most likely to get a loyalty score, or maybe you can group them all together and then perform actions on this set of customers all together, so they are forming one group as a whole, right? This customers with age 30 and who are belonging to this education group. And there are multiple sort of different visuals or analysis that you can pick out of your predicted data, right? Your this total clusters, and these are the different kind of analysis that I drew out of this, like this one, this gender, and if I want to see the loyalty status, the loyalty programs. So most of the males are around the regular loyalty programs, and this line is basically representing the um, what is it, the interval sequence basically. Okay, so by that, you can target your customers easily by segmenting it. Okay, so I hope this one, this is the end of the customer segmentation, by the way. So I hope this one, I mean, you enjoyed this project, this one. If it is, then I would like to see some comments or some reactions from your side. Then we can move to classification. Is it a lot to take? I have done similar, something similar. Oh, that's nice actually. Yeah, these are the actually same things that you can expect when you are working with the industries as well. In the corporate industries also, they do the similar sort of a things. It's just quite in a in a broader sense they do it. Okay, so here we have just a single model. I have shown you just a single model. There we would use multiple models. We would also use the DB scan methods too to find out which one is the best. So that's the only difference. Otherwise, it's all the same thing. Yeah. Okay. Great. So we can go to the supervised modeling, I guess. Let's see what the supervised modeling is coming up with. So there are two types of supervised modeling: classification and regression. Now, classification is, as the name suggests, you are classifying it to some category or some class. Regression is when you have a continuous numerical value to predict, basically. Classification is when you have a particular value that is not a continuous thing, which is a discrete one. Regression is when there is a continuous value that you have to predict it. So it's quite easy to understand how the prediction works using the concept of regression, right? So I'll show you this one, this line basically. So regression is all about y equal to mx plus c, this equation. So if you see this equation over here, y equal to mx plus c, somewhere I've written, yes. Y equal to mx plus c is what a linear regression is, the simple linear regression. Now there are polynomial regressions too, there are multiple linear regressions too. It's all differ in the x values, that is x square or multiple x's, that is this is just a single x, there would be x1 x2 x3 so on. So it just differs. Okay, but what the prediction is, the prediction is simply mathematical when it comes to machine learning models. How it is, you are changing the value of x and accordingly you are going to get the value of y, right? In I mean, in childhood we have done, in schools also we have done the algebra, right? We wanted to find out the value of y for a given value of x, and we would say that for different values of x, the values of y were changing, keeping the other values constant, that is keeping the value of m and c constant. If you change x, y is going to change. So that creates something kind of a pattern, right? And this here in this picture, this B naught is your intercept, which is the C. Yes, right. M is the slope and C is Y or intercept. Yeah, right. So B naught is the intercept of the C. So over here, as we see that the B naught is 10, or we can say the C is 10. And then you have the value of M, which is slope. And the slope, let's say it is something like 2. Okay, let's just guess it as 2. Now, with the change of x, as the x is changing, that is x is 100, y is somewhere here, x is 200, y is somewhere here. So if your value for this M and C is constant, then the value for this y is going to change for with the change of x, and that is what prediction is all about. This is a complete, I mean, this is a complete magic behind this prediction. So what the need for these machine learning models then, if the predictions could be done using this y equal to mx plus c only? The reason is we are having complex data sets, we are having multiple features, it's not just a single feature. And also we want something that is having the ability to make it learn. Okay, so that is having the ability to understand all by itself or learn by itself. How the machine learning models or this y equal to mx plus c is learning? It is learning by looking into the loss function. We want to reduce the value as much as we can when it comes to the loss, right? So if the predicted value is, let's say, 10, but our actual value is 20, there is a loss of 10. The error is 10 over there. So we want to reduce it. Then we retrain the model once again. How? We cannot change X, right? We cannot change our input data. Then how are we retraining it? We are changing the value for the M and the value for the C. We are adjusting the model parameters. When I say this aim and C value changes, these are the model parameters that we do the changes. Okay, that we do the changes to. So after changing the aim and C, and then if we put on the value for this X and again calculate the value, now the value for Y is coming somewhere around, let's say, 15. So previously it was 20, now it is 15. So there is a difference of 5. That's pretty good. So machine learning models now, like the linear regression model, is having that ability to get it. I mean, to give you the prediction where the accuracy will be at the highest, or we can say the error will be the lowest. So there are several types of regressions available that are over here. But today, what we are going to do is for the classification. Regression is it's quite common, I will say, and regression is mostly observed. These regression models are mostly observed in the form of time series analysis. So time series analysis is a bit advanced concept. It has its own different set of models that maybe we will see in the next webinar. Sorry. Okay. Okay, so Karthik is saying loss equal to actual minus predicted. Yes, exactly. So that's the error part. And we want to reduce it. We want to reduce our loss in terms of um, any kind of predictions, be it classification or regression. So that's how the predictions basically work. And then moving on to the classification, also, we try to reduce this loss only. We try to minimize the loss. Okay. And there are the different types of classifications: binary, multi-class, multi-label classifications with their definitions. So the one that we are going to look at today is the customer conversion rate. This is going to be a binary classification, and why this customer conversion rate is important, I have kept the complete structure for today's projects in a sequence. So first we did the customer segmentation. That is, we looked into the fact that if we want to perform marketing, let's say you have a good product and you want uh, a good set of customers, you want the perfect set of customers who would buy your product, you would do the customer segmentation, picking up the data. Then you would run your ads, and then you would see the customer conversion rate. Conversion rate means what? Whenever someone is looking into your ad, what is the probability that they are going to be your customer forever? Right, let's not say forever, but they're going to get your product or purchase from you. Okay, so that we are going to see today. But before that, the model that I have used quite a few models over here, so that you can, and have described on top about it over here as well, so that you can go through it, you can learn about it. But the ones that I have explained over here is, first, the K nearest neighbor classifier, which is, the working of it is somewhat similar to that of the, I mean, it's almost similar, not somewhat, it's almost similar to that of the K means cluster that we have seen before. Okay, just in the customer segmentation part, the model that we have seen, this K nearest classifier, KNN classifier, is almost the same as that one. That's why I have used it first. And this is the working structure I have defined for it. We will go to the model and see how it is working. Okay, that will be a better to understand. But to give you an idea, that we have this K nearest neighbor classifier that is working on the distance measurements, like if it is in the proximity, that is if the points are nearer to each other, then they are similar. Then we have this random forest classifier. Random forest classifier are based on decision trees. Normally decision trees, I hope you know about this, what decision trees are. But if not, decision trees are basically, you can think of those as if and else kind of a structure. You have certain features. If those features are falling onto some condition, then you go left, else you go right. And then you put on more conditions, and you end up with a hierarchical structure. And multiple decision trees together are making up the random forest classifier. Okay, so for classification of categorical data, yes, for classification of, I will say data, we need decision trees, because decision trees are having the ability to classify the categorical data, and also it is having the ability to perform the regression also. So it just depends on your output, the target data that you have. If it is a continuous one, you can use decision tree regressor, random forest regressor. If it is a categorical one, then you are going to use random forest classifier, right? Okay, so there are multiple things which are, yeah, quite hard for us to remember as well. That's why I always prefer documentation to go through. Then comes the AdaBoost classifier. Now, AdaBoost classifier, this is, I thought of introducing it over here because neural networks, if you know about it, neural networks in deep learning, it has the concept of weights and biases additions into the data points. Something like that, the weight addition is present in the AdaBoost classifier as well. So it picks up this decision trees, it assigns some kind of weights to the values, to the incorrect ones and also to the correct ones. And then with the weights and the different decision trees, it learns something, it gives you some kind of average result out of it. That is the AdaBoost classifier. So that's an improvement over the random forest classifier. And there is yet another improvement that I have used, that is a gradient boosting classifier. So this gradient boosting classifier, I have described it over here where I did it this in this project model. But what this gradient boosting is basically doing, it is again an iterative model, just like the random forest and the AdaBoost one, and it is picking up multiple weak models. Like weak models are normally the decision trees only that the previous models were also built out of, and then it is creating the bigger model out of the multiple decision tree models. So what it does is that at first it is picking up one decision tree model. This is the one. This is the blue color one, and then you are getting some predictions out of it, right? You're getting some kind of residuals. Then this another model will run on top of those residuals. So then you have this another prediction, and on top of this another weak learning model will go on learning. So this is kind of an iterative function. It will be more clear when you do it over here. That is when you do it in the steps. So let's go to the project and try to understand it from here itself. We have got a very brief overview of what the type of classifiers are and how the training is going on, right? And now we can get started. So this is the introduction and the dataset details, and the dataset is again from Kaggle. So I have imported some of the libraries that I thought are important to have. And next, we're importing the data set. We're performing this EDA, exploratory data analysis, which is kind of same as that we did in the customer segmentation. So I kept it short, but I have shown here some different ones. Maybe you can go through it later on. I will go to the model part directly. So these are the different type of uh, visuals, right? Okay, so getting into this feature engineering part, at first they are the same thing. The encoding, the columns to encode, basically these are the ones, the categorical columns that we did the encoding, and then created another table out of it. And this is how the encoded table is looking like. The same thing that we have done before, just the only difference is that I have used over here column transformer. Column transformer is another feature just to show you different kind of ways of doing it, right? And this is just a function which is picking up the transformation, like what you want this categorization, you want the one hot encoding, and you have to give the columns that you want to encode, and that's that. Okay, and remainder equal to pass through, this is signifying that you want only the categorical columns to pass through it, and you don't want the others, that is you don't want the numerical ones to get encoded somehow. Okay, so this is how the final data set is looking like after the encoding, right? And in this one, I'm not performing the scaling. Why? Because I'm not performing clustering in this case. I'm performing the classification. And classification is going to classify, and for that classification purpose, this higher data points might be useful for me, right? I mean, this might signify something. So if I do scale it, it might change it, it might alter the values. And in that case, the classification might be wrong. It might classify, let's say, this one with this smaller one, which is actually incorrect. So I'm not performing scaling in this case of classification. So after that, we're splitting up the training set and the testing data set. And here comes the model training. So we first started with the K neighbors classifier, and then we're going to check on the accuracy score. But again, if it is a K neighbors classifier, we would want to know which value of K is ideal to pick, right? Just like in the K means classifier, we would want, K means clustering algorithm, we would want to know which is the best value for K. So in the same way, we are performing the looping, and then we're fitting the model, we are predicting it, finding out the accuracy, appending all the accuracy values into it, because here we are not having the concept of inertia that K-means was having. And from here, we see something like this, right? Now, what should be the value of K? It's quite difficult to tell it from here, but somewhere it should be around here, because it is becoming stable after that point. Before it was changing a lot the accuracy, but the accuracy is coming out stable around this point of 13. So it should be somewhere around 13. And let's see, you can find it out in this way. Okay, with this argument max, np argmax is basically going to give you the index for the maximum value, and that's what you get is 13. Okay, and the accuracy is 87 percentage. And this is all the set of different classification model that I have tried on it. So while performing the clustering, when I was saying that I just performed the k-means clustering over there, but there are multiple other types of clustering algorithms available that you should be trying out. There are other data alterations that you should be trying out before finalizing on your model complete flow. So in this case also, the same thing applies, and I have used multiple models, but uh, I mean, is it ending over here? No. Even after using the multiple models, we can go more further. We can go ahead with the parameter tuning. So this once I have used the models over here like Gaussian NB, I haven't provided any parametering to it. So this is basically going to pick up the default parameter, and Gaussian NB is a very basic type of model. It is not having that many parameters also. In case of decision tree classifier, I haven't introduced any parameter except for the random state 42. In case of random forest, I wanted the n estimator to be 100. That is, in estimator 100 is one of the parameters which is estimating 100 number of decision trees, you can say. Okay, so this is called the parameter hyper tuning, and this is also an important term when it comes to accuracy increasing. Over here, I haven't performed the uh, parameter fine tuning, and there are multiple parameters that you would be looking into when you will see all of about all of these models in scikit-learn. Then you can perform different kind of parameter fine tuning to see how the models are behaving with the changes of the parameter values. Okay, anyway, so here we are having this many models that we're going to try out and we're going to see. So the reason that I have provided so many models all together to show you that how you can basically compare the output accuracy for all of the models taken together. So this is giving you the accuracy for all of the models when you are training on top of it, right? So this is the accuracy score with the model dot predict for all of the models that you are working on it, right? With the X-train data set, you're fitting the model at first. Okay, yeah, this is the training score and this is the testing score. Now, why this training accuracy score is needed and the testing accuracy score is needed? Because we would want to know if our model is getting overfitted or not. So if the training accuracy is very high but the testing accuracy is low, then of course there is a model overfitting. For example, in case of this Gaussian NV, you can see the training accuracy is 88 but the testing accuracy is 88, so it's fine. In case of decision trees, the training accuracy is 8 but the testing accuracy is 82. It is overfitting by a huge amount. Okay, so decision trees are prone to overfitting. That's a normal thing that we need to take care of. So that's how you can compare multiple models taken all together. Now, out of all of the models that are present with us, what we can see is that this gradient boosting classifier over here, this training accuracy is 94, but the testing accuracy is 91. Okay, so what is the case for this one? Of course, it is overfitting by but by a slight amount. We can consider this much, but there are ways to reduce it as well. You can perform regularization, and that regularization is basically model parameter fine tuning. You can look upon what the parameters that goes into this gradient boosting classifier. You can change the values for the parameters, and then can retrain the model. That is you are basically regularizing the models. You are introducing regularization and then can see how the accuracy is changing. Okay, now you would want to see what are the important features in your data set is, right? And in order to know the important features, these are the best models to use: decision trees, random forest, GB classifier. They will give you the important features that the model think is important in your data set for the prediction purpose. And this is the complete one. Okay. We got some comment to reduce overfitting. Yes, regularization is needed to reduce overfitting, and the way we regularize is again by fine tuning the model parameters. That's one way we do it. There are other ways too, but yes, fine tuning the model parameters is, one of the first steps that we take for reducing the overfitting. Okay. Okay. So next we looking into the model evaluations in terms of precision, recall, and F1 score. F1 score is basically the average of the precision and recall only. We're looking into the accuracy. So this is the same as the accuracy above. It's just that we are looking into more details on evaluations. Okay, evaluation metrics basically. Okay, fine. So going ahead, okay, so over here in this classification report that we have got, what is the difference between this precision and recall? And okay, accuracy is how accurately the data is getting classified. That's fine. But what is the difference between the precision and recall? Why do we need to see both of it? And there is a common saying that there will always be a trade-off in between the precision and recall. Why so? Does any one of you know about it? And what the precision is and what recall is? Can comment? Okay, I cannot see any comments yet. So it's basically the difference between precision and recall. What do you think? What it would be? Okay, fine. So precision is basically the what can we say? It is basically the fraction of the records that is I mean, the fraction of the records that has got correctly classified out of all the records. It's basically the true positives. I mean, whenever you are having, let's say, 10 records, and out of it, 7 got correctly classified to the category it should belong to, and 3 got wrongly classified. So the precision would be, in this case, 7. That is the number of true positives that we are getting out of it, and recall is the fraction of relevant records that are retrieved, which is calculated basically by the true positives and the total number of actual positives basically. I mean, precision is how precisely it is getting say it in a common term is precision is how precisely the true positives are getting classified, and recall is the total number of records that are getting classified. Class level accuracy, yeah, yeah, that's the formula we do use. Yeah, so recall is the total number of terms, or the total number of records rather, that has got classified correctly. That is a recall score. Okay, so there is a trade-off in between it. If the precision is high, the recall would be a slightly lower. If the recall is high, precision would be a slightly lower. So we need to perform the modeling in such a way to get the precision and recall uh, somewhat near to each other. Okay, the values shouldn't vary a lot. So this is the complete code for the model evaluation. That is the complete result, and this is what it is looking like at last. And out of all of it, the gradient boosting classifier tend to perform the best. So what we got over here is that the precision and the recall is almost the same in this case. It came out as almost the same. The F1 score is 90 and the accuracy is 91, which is quite good. So we can go with the gradient boosting classifier model with this data set. So using this GBM data GBM, we have initialized this gradient boosting classifier with this GBM in variable, and then fitting it up with this X-train and the Y-train. So previously we used so many models to see how it is performing, and out of it we are selecting just a gradient boosting classifier model, and then we're making the predictions. The accuracy is quite good. Okay, fine. Now, if how can you make use of this model? You are having a completely new data. Let's say you are streamlining this model into production. So the next day you are getting some data which is flowing through this model, and that data is having, let's say, this income as 60,000, age as 35, loyalty points as 200. So what is the probability that this person is going to be a customer? So according to our model, the person is going to be our customer. The turning rate is 1. So whenever this kind of projects are taking place at industrialized level, I mean in the corporates, what happens is that they have to run certain ads on the basis of certain features. They have to alter the features. They have to create certain what to say, they have to create certain zones for targeting. Now, if you see that your model is performing 91, if it is having the accuracy score of 91.8 percentage, then you can just make up some kind of random value, let's say 60,000, 35, 200, something like this. And then you see that, okay, any person who are falling in this range are having the higher chance of being a customer, right? They are having a higher conversion rate because our model is saying it as 1. So you give the business persons or the digital marketers this data saying that target the customers, or target the persons who are falling in this zone, who are having these features, then it will be I mean, the higher probability will be that we will get them as our customer. That's why this classification is important. That's why this prediction is important. We want more of the customers, and we want it, I mean, specifically we want to show them the specific things that they want to see, and then they want to turn over to us. That's why whenever you are on the social media, you see multiple different types of ads, and not everyone is looking into the similar types of ads, right? So those ads are targeted basically as per your choices, as per your interactions with the different websites, your purchasing pattern, your interactions even with the posts. So they take up all of those information, and then they do this kind of predictions on the classification basis, like if there is a probability that the ad being shown to you, you will click on that ad or not, right? So that is called the customer conversion rate. That's how we do it. Okay, so there comes the end for this classification project. Are we good till this point? Okay, you can put on some comments if we are good up to this point. There is a little bit of a small thing that I would like to show before ending. It's very high level. Okay. Yeah, it's a little bit of high level. Uh, of yes, because we are aiming to show you how the industry level of work is like, but yes, we are not using this kind of models in such a simple way. I mean, yes, this is not really that much of high level when it comes to corporate task. It is we do perform a lot of what to say it if I there is a term called there is a function called as grid search CV, where we have to do the fine tuning of the parameters and then we have to do it. That's how it goes in the corporate level, I mean industrial level of work. But yes, these things are not easy. These things will take some time to go through. However, I hope you have understood the purpose of this project, like what we do and what all things are possible with it, right? This classification, and this is the classification that we performed using the customer's data set. You can perform this classification even with the images also, that we will see maybe in the next webinar, how we are classifying the different kind of images, right? And that will be a good example for multi-label classification, the way Google is tagging your images actually. Okay, any book to read? Normally, what I would suggest is that, I mean, yeah, you can, this internet is full of resources. You can get to any of the resource that you want. But the normal suggestion that I would have is for all the models, you should be going through the documentations. I mean, I have provided a link for the documentation over here. Okay, it got disconnected. I have provided the link to the documentation. If you go to this documentation, it will give you the complete detail of what this model is, what the parameters it should be you should be using into this, and what all things that it can do, right? Okay, so going ahead. Oh, really good. Okay, going ahead. I have just a small thing to show you to give you an insight on what more could be done. And this is the recommendation. So you have seen the movie recommendations, right? And these recommendations are very popular. And today I'm going to show you the product recommendation, since we are performing the actions on at a marketing level. That is, we did the customer segmentation, then the customer conversion rate, and now we do the product recommendation. It's similar to that of the ads being shown to you. So, what kind of product should be recommended to you? In short, if I say it. And the same processes you can do for movie recommendation systems, and you can also do for, let's say, job recommendation systems. What are the different types of jobs that the model will recommend you? You can build it right in the same process. And this is not just a single process for building a recommendation system. There are multiple, but this is the simplest one out of all. So I'll go through it very quickly. What we did here is we imported the data set. This is the Walmart product data set, and did the same old steps of data processing that is needed to be done. And over here we checked the null data. We have few null data that we handle it. How we handle it, we used this fill in it with zero. That is, whatever you are getting the null, fill it with zero, or fill it with unknown, or fill it with a blank, because models cannot handle null data. If there is any single null data, the model will fail. So you need to handle that. There are no duplicates. Okay, fine. And then did some column renaming for a better view of it, basically. And this is how the data set is looking like. Now, while doing the previous ones, when I said that models cannot handle words, right? It cannot handle strings. But in those projects that we have seen before, there we were having single words, one word or two word like that. But in this case, we're having sentences. How are you going to perform the numerical transformation for these ones? So we call it as text embedding, and I have given it over here, like what the recommendation is. You know what the recommendation is, and there are different types of recommendations that I have provided over here. And today we are going to perform this content based recommendation, basically. Okay, so to give you a very brief understanding of what a content based recommendation is, it is basically whatever you are watching, it is going to recommend you on the basis of your content, on the basis of your interaction. Collaborative filtering is another type of recommendation system, in which you have again two types. One is user based, another is item based. User based is whenever user based is basically it is showing you the products, let's say, similar to what it would be showing to someone else who is almost similar to you. I mean, let's say you and your sister is sitting in a room, okay, and you both share similar interest. That is, you both love to watch movies, you both are love to do some kind of shopping, and then the next day your sister is going on clicking on some book. She's buying some book. Then the machine at the back will think that, okay, if she is buying a book and if they are so similar with their interest, mm, then you might also purchase a book. Then the machine will again start to recommend you a book. This is called a collaborative filtering. That is, it will recommend you on the basis of the other users who are kind of similar to you. And then the item list is almost the same thing. If you and your sister together are showing similar kind of actions in the internet zone, and then if your sister is purchasing something, that is some items, then it might be there is a high probability that you might also buy that item. I mean, there is some kind of relationship in between those two items, would be associated as per your interaction level with the internet. Okay, so that is a collaborative filtering. Okay, now, when I was saying that we have the sentences over here, and the sentences cannot be converted into single numbers. So what we do something called as text embedding. Now, this text embedding is basically a way in which the complete sentence is getting converted into numerical vectors, basically numerical numbers. And there are many ways in which you can perform text embedding. The way that I adopted here is TF-IDEA vectorizer. So how it looks like is, whenever you will perform the text embedding, you will get to see it. Before that, what I did is just converted this ID and the product ID to numbers. So it changed from this long to just few numbers, and the code explanation is provided here. And this is the function where I did some text cleaning. What kind of text cleaning? I removed the stop words. What are the stop words? Stop words are the words in English which is not adding any significant meaning to the text. Like this a, the, and all of these things which are not having really important context. So we can drop that. So this is what the cleaning process is like, and I have defined it completely over here so that you can go through it, and then cleaned the tags data. So what this tags data is, this tags is basically coming out of the description column. Okay. And what description column and the name column and the category column. So we picked up these three columns over here. Here, if you see it, and the brand also, yes, I have taken it, and then have used it in the tags. I've created a new column, cleaned these columns, created a new column, called it as tags, and now I'm going to use it. How? Let's see. First is in the rating based recommender. Okay, so up to this point, you can see that I haven't changed any of the words into numbers, or I haven't encoded any of it, right? We will encode it later on. But first, let's see the rating based recommender, and it is the most simplest one. What you're doing is checking out the ratings. So when they're asking you for rating, actually, they want to perform some kind of this rating based recommendation with you. There are this rating column provided, and I make use of this rating column to provide you with the details as per the rating. Okay, so this rating recommender is basically going to give you the top 10 names or the top 10 products as per the rating, and this is very simple. It is I mean, you can just go through these lines of code, and it is quite elaborative. The codes are quite elaborative in itself, and I have defined it also over here. So this is one type. The next one is a content-based recommender. So what the content-based recommender is, in this case, we need to perform the text embedding. So the TF idea vectorizer that I'm going to use in this content-based recommendation, and along with that, I need to use the cosine similarity. Again, the similarity is coming. Why? Because we need to find out the distance again. And this distance is not really a distance which is measured in lines. This is a distance which is measured in angles. So, in short, we have the sentences that we want to change into TF-ID vectorizer. So, I have that column of these tags that I am transforming into vectors, vectors of numbers. How these vectors of numbers are looking like? Let's see. This is how it looks like. You have the sentence, you fit a TF-ID vectorizer. Okay, so here a count vectorizer. The picture that I have taken has used count vectorizer, but this is another, again, a different vectorizer. This is not a TF-IDF vectorizer, but they're almost kind of similar. And TF-IDF is term frequency, inverse document frequency is more appropriate than the count vectorizer, but it is somewhat similar that if you're having a sentence, your words, that is every word in your sentence, is going to be associated with a number, with a decimal number to be more appropriate in terms of this TF-IDF vectorizer. Okay, so the sentences are getting transformed, and after the sentence transformation into numbers, you are calculating the cosine similarity. What is that? Let's move back and see it. So if your sentences are getting converted into numbers, into vectors, and vectors can be represented in space, right? It has a direction, it has a magnitude. So it can be represented in space. If, let's say, the first sentence is A and the second sentence is B, or the first product is A, second product is B, how much similar are they? You can calculate the angle. You can draw a line from this 0 point and then can find the angle in between them. This is the cosine similarity. If they're unrelated, then this angle will be larger. If they're opposite, the angle will be huge, almost 180, right? So we want the similar products for the similar products, and for that we are calculating the cosine similarity. If the cosine similarity is a smaller one, then the products are similar, and then we're finding out the indexes of it, that is retrieving the indexes for the specified items, basically on the basis of the cosine similarity scores. And this is how the recommendation system is working. These are the recommended item details. So recommendation system is nothing but what you can call it in two line is that you are first converting all your words into numbers, and then you are finding out the distance in between the numbers in space. That's what a recommendation is. So you as a user, I'm picking up something from here. Let's say you as a user is giving it an input. Let's say this one, this B matte lipstick something, and then you're passing it to this content-based recommendation function that you have built over here, and it is going to recommend you the top 8 products that you are likely to pick up because you have clicked on it or you have entered it. So that's why when you, let's say you go to Netflix, you click on any movie and it shows you the similar sort of movies on the basis of the content in the same way. So you can make use of this code get some other data, maybe get some data for the Netflix movies, and use the description columns and the other different, let's say the title column and all the other features that you find are important from that Netflix data set, and can use it, the same function over here, this content based recommender, and see how it is giving you the results with the recommendation. Like over here, I had given here top 8, so it has given me top 8. You give it 10, 15, so on. It will recommend you accordingly. Okay, so that's what a recommendation system is. And here comes the end of my predictive modeling with AI. So today, I guess we have covered a lot of things, starting from clustering to classifications, learned a little bit about how the regression is looking like, and then went through these recommendation systems. These machine learning models and its types are not ending at this point. There are many others like anomaly detections, which is falling under clustering, which is again a very important one. There are market basket analysis in clustering, which is very important. Then the time series analysis is there, which is used widely in terms of stocks analysis. So that is falling under the machine learning part only, right? And yeah, there goes the end of the project. And any questions you have, you can ask. I'm stopping the screen sharing. You can share your feedback on how you liked it today. And if you have any questions, if you have anything to share or ask, you can do it. Okay, time series model also work like classification. We studied time series is a regression. It's not a classification model. Okay, so it will rather, if I tell you, it will rather work like y equal to mx plus c, but a rather much more complicated one. Okay, it's not a classification. Okay, any more questions? I hope that answers your question, Ashish. Okay. So I hope you all have understood today's session. I would appreciate some feedback from you all. Thank you, Ashish. For others, I would appreciate some feedback. Thank you. I hope it was useful for you all. It was informative, of course. This webinar was not intended to let you know everything, but to give you an insight, a useful insight on what all things are possible, what all you can achieve with it, what all things are there to know about. So you can go ahead and go through all of it, right? In order to show you a direction, like how you should be going forward with it. Okay, any more questions? Okay. Okay. Okay, thank you all for attending today's session on a Sunday. I appreciate your patience and your attention. Thanks a lot. I think we can wrap up for today if no one is having any question. When we'll
Uh,
create one LLM. Okay, Rohini, today we have started with machine learning. The next webinar, I'll start with the deep learning ones to give you an idea of how it looks like. So the first one is like how machine learning is like, then the how deep learning is like, and after that, what the generative models are like, how what they are built out of, how they are interacting with each of the blocks, and then at last we will be performing the LLM models. We will be creating our LLM models. Yes.
yes. So, yeah. So, guys, if anyone have any doubts or any questions, you can post in chat, and we will close this meeting in next 2 minutes. feel free to drop off like if you don't have any questions. Yeah, I think we can wrap up. And thank you guys, everyone, for joining. Thank you, Nishi. And
Thank you.
see you in the next weekend. Thank you. Thanks a lot.
Thank you so much.